Now, we will see what happens when there is a privacy breach. First and foremost, these are all the questions. Now, I am a customer of a cloud service provider. How will I know that a breach has occurred? If a breach has occurred, in other words, how do I ensure that the cloud service provider, whenever there is a breach, will inform me that the breach has indeed occurred? Now, who is to be responsible for managing the breach notification process and the cost associated with the process? So, when one of the most important thing that happens when contracts are signed, from a security point of view, in these contracts, the things that could be there is mainly for privacy breaches. And when we are looking at privacy breaches, all these points need to come. How can we identify that a breach has happened, and when an identification like that happens, who should inform, when should they inform, how quickly they should inform, and then what would be the next strategy to be followed immediately to manage that the breach, the losses that are caused by the breach. Now, all these things would be part of the contract. Now, the next question is, you sign a SLA, how do you go and enforce this contract, and how do you go and determine whose fault is it at any point of time. So, these are all something that are very important, especially from a data privacy point of view, when there is a breach in that privacy. And note that this type of privacy breaches will have cascading effect. The cascading effect in the sense that one privacy breach can lead to another privacy breach, and because of one privacy breach, that second privacy breach need not be on the same customer in a cloud type of infrastructure, right. So, finally what would happen is that there is the credibility of there can be an organization which has signed a contract with a cloud service provider. Now, let us say that the cloud service provider, it is his responsibility to see that there is no privacy breach. But when there is a privacy breach, the organization can certainly transfer all the liability because of that privacy breach, but they cannot transfer the accountability. Still they are accountable to their customers. So, there is a bank, there is a cloud service provider, and the bank has a agreement with the cloud service provider, which basically says that if there is a privacy breach, you are responsible for all these things. Then there is a customer to this bank whose data this bank goes and saves on the cloud. There is a privacy breach, yes, liability because of that will be taken by the cloud service provider, but still the customer will not go and ask the cloud service provider, he will make the bank accountable for that. So, that is very, very important, and that is why all of us should be very keen on this protecting the privacy. Both the customer to a cloud service provider and the cloud service provider, both should, in the interest of both, should have this privacy policy very strong. So, this is a very nice case study. So, I am just reading it out. Suppose a hacker breaks into cloud provider A and steals data from company X, who is a customer of this A. Assume that the compromised server also contains data from companies Y and Z. So, these are all the questions. Who investigates this crime? Is it the cloud provider, even though company X may fear that the provider will try to absolve itself from responsibility, right. So, if cloud provider is going to investigate this, then he will say, I have no problem, it is because of your problem. He can blame X for that, like some end user of X has shared the password and it is not. So, company X would like to go and do this investigation, but when company X wants to do this investigation, on that physical server in which companies Y and Z also have the data, obviously it will start looking into logs, and those logs will have data of companies Y and Z also. So essentially the privacy or whatever the confidentiality of the logs of companies Y and Z essentially gets violated. So now this is a peculiar scenario that a cloud provider A steals data of company X. A hacker breaks into cloud provider A and he steals data of company X. If the X will not want A to do it, and A cannot permit X to do it. X does not want A to do it because A will not, if A alone does it, then he will not project what went wrong with him, he may absolve himself. A will not allow X to do it because then it will see the data of Y and Z, and there is a confidentiality clause that is signed as a cloud service provider. A has signed a confidentiality clause, privacy clause with Y and Z. So he will not allow X to come and see the log because the privacy of the data of Y and Z would be compromised. So this is a very peculiar situation. So there can be many such situations which make even fault investigations into crimes more difficult and more transparent from the different stakeholders' point of view. So now we have talked about all threats, threat models, etc. on the cloud. Now in the remaining part of this session we will now start looking at possible solutions. So what we have seen so far, we have seen cloud as an infrastructure, we have seen the different fears or lack of trust that comes, and then in the next part we did see some of the privacy and threat issues, security issues in the cloud environment. The last part, now part 3 of cloud and related security, we will see what are the possible solutions. The solutions could be actually in 3 parts, and we will cover the first part in this session, while we will cover the remaining 2 parts in the next session. So the first part would be to minimize lack of trust, the second thing is to minimize loss of control, and the third thing is to minimize multi-tenancy. So we have to look at all these 3. If I minimize lack of trust, I start trusting the cloud service provider, certainly the fears would reduce. Now what are the different ways by which I could minimize lack of trust? Similarly, what I mean by minimizing loss of control is that I keep monitoring, and I can also utilize different clouds. If one cloud fails, I can go to another cloud, and I need to have lot of access control mechanisms and manage the access control, and I also manage identity. So if I am going to do all these things, then of course I do not lose control. I basically can have control over what I am trying to do on a cloud, and of course minimizing multi-tenancy. So these are all some possible solutions. Let us go and look at the pros and cons of these solutions to start with, and then we will look, in this session we will talk about minimizing lack of trust. In the subsequent session we will talk about the other 2 in detail. Now first thing is that we are looking at in theory minimizing any of the issues given below would help. Specifically when I am looking at third party cloud computing, what are the things that I need to go and minimize? First thing is I want to go and improve the trust, right, as we so I want to minimize lack of trust. How will I go and minimize lack of trust? That means I want to go and increase the trust. One thing is I will put lot more technology there. I will also put lot more policies and regulation and technology to go and say that these policies and regulations are adhered to. We will also have contracts with some incentives. So these are some things that we will discuss in our future talks. Now, by doing all these things we can increase the level of trust. The second thing that we are looking at is loss of control. When there is a control loss, when there is a server that failed, we need to take back control. Your data and applications may still need to be on the cloud. So, we have to shift it to another cloud. What it means to shift to another cloud? Can they be managed in some way by the consumer? So, can I have multiple clouds, one fails I can go to another cloud. So, these type of issues are very important when we look at loss of control. Loss of control is even that the data center essentially becomes non-accessible. Now, how quickly can I go to another cloud with all the necessary information, and I can seamlessly start running the show. The next thing is about multi-tenancy. If I say I want a private cloud, then the reasons of a cloud itself is lost. A cloud is to share the infrastructure. So, multi-tenancy is important. People now talk of this virtual private cloud, which is again not in again it is the same thing. Even in a VPC there will be servers in which physical servers in which applications, virtual machines and applications of several other users will be of different customers will be in the same place. So, one of the things that we need to ensure is there is a strong separation between any two virtual machines that are running on the same physical server. So, these are all the broadly how we go and handle these security issues, but we will go into depth for each one of them here. When I talk about third party cloud computing like the Amazon EC2 or the Microsoft Azure, what do they provide? They allow users to instantiate virtual machines, they allow user to purchase required quantity of resources whenever they require, and allows service providers to maximize the utilization of sunk capital cost, and they also confidentiality is very important. So, third party cloud computing, at least for not very sensitive applications, has been a good success of today. So, what are the known issues when you go for third party computing? Of course, confidentiality issues are important, and we are going on a third party. So, there could be malicious behavior by the cloud provider himself, and there could be some other customer of the cloud provider who could have a malicious behavior. And of course, there are this is an outsourced model. I am actually getting this in the cloud being maintained by the third party. So, it is an outsourcing, and so there are known risks for outsourcing, and ultimately the important thing is that there is a cloud service provider and his infrastructure that he has deployed for us to use, that needs to be trusted. So, this is the main thing when we look at third party, and we have seen in the previous session many vulnerabilities, new vulnerabilities, in addition to a old vulnerability that we see, conventional vulnerabilities of somebody trying to hack into your system. It is that that physical resources are shared between virtual machines. So, an adversary can have more physical can have an application, legal application running on the same physical server, which can basically go and sneak into your application illegally or sneak into your data. So, the notion of multi-tenancy gives out a set of new vulnerabilities and attacks. And then we could have, because of this multi-tenancy, we could have some collaborative attacks, and another thing is like I could map the internal cloud infrastructure, and based on that I could go and position my attack, and there can also be cross virtual machine side channel attacks, which can extract information from the target virtual machine on the same machine. So, all these things come because of many softwares trying to run on the same physical hardware. So, to just look into this, to summarize this, can one determine where in the cloud infrastructure an instance is located? Can one easily determine if two instances are co-resident on the same physical machine, where one incident is a normal instance, one instance is a normal instance and another is actually a malicious instance? Can an adversary launch instances that will be co-resident with other user instances of his choice? Can an adversary exploit cause virtual machine information leakage once he is a co-resident? The answer to all these things unfortunately is yes to all, and that makes security on cloud a very important aspect. So, in the so to sum up what we have done so far, we have looked at different security issues on the cloud, and we are looking at many important privacy issues there, and we looked at the data cycle, and at different data life cycle and at different points we are looking at privacy of this data life cycle. And what we really find is that to actually go and address many of these security and privacy concerns, we need to have certain good policies, and we need to have reduce the lack of trust, and also minimize loss of control and minimize multi-tenancy. Now, what it means to minimize loss of control? The thing is that loss of control, there are 4 important points. One thing is I need to keep consistently monitoring whether I have control or not, and when I lose control, there should be a provision by which lose control means that one particular thing is not available to me because of whatever be the reason. Now, I have to move the entire thing into another cloud and start executing. And when we access a single cloud or move from one cloud to another cloud, then there is an access control management, and that access control management should seamlessly take care of these issues. There is an access control management for me to access one cloud. When that cloud fails, I need to go and access another cloud. So, how do we extend this access control management for the next cloud? And then there is of course something like identity management. How do we manage identity across clouds? So, all these things come as a point when I say when I want to minimize loss of control. First, look at monitoring. So, whenever there is a situation where there is an incident, some component fail, we need to clearly understand what is the effect of the failure on the mission logic and what sort of recovery mechanisms measures should be taken, what type of recovery measurements to be taken, measures to be taken by the provider, cloud, and also the consumer. This requires an application specific runtime monitoring and management tool for the consumer, because ultimately the consumer needs the control, right. So, the consumer consistently observes every application, and so for every application he would like to have a log, and he would like to keep monitoring whether there is a component failure, and this is how we go in for minimizing loss of control from the monitoring point of view. So, now what is the challenge here? If I allow a consumer to monitor what is happening on my server in a multi-tenant model, especially when there are more than one tenant sitting on the same physical infrastructure, giving out such type of monitoring facility to the consumer can lead to privacy violation. So, there is some point that we need to take care there. And when there is an attack, we need to provide mechanisms that enable the provider to act on attacks he can handle. For example, I have a software X, and there is another fellow who has instantiated another virtual machine on the same server where X is running with an intention to attack X. So, immediately there should be infrastructure remapping where I move this particular create new or moving existing fault domains out and creating or moving this virtual machine to a better system. Similarly, shutting down some offending components or targets, the provider needs. So, in some sense, even if I am using the cloud as an infrastructure as a service model, still the provider, the cloud service provider should be given control to move the virtual machine that I am using as an along with the operating system and the software. He should be in a position to move the virtual machine to some other thing as a part, to some other server or to some other physical server. So, that is the other thing is that we should provide mechanisms that enable the consumer to act on attacks that he can handle, right. So, this is what we call as risk adaptable access control. So, there is a very clear, there is even a patent, you can look at the website there, where this gives a way by which I as a consumer, not as a cloud service provider, I as a consumer find that there is an attack on the system, on the cloud. So, I now want to move it to another the virtual machine that is running on one physical server, I want to move it to another server. Now, there is a clear cut way by which I need to go and appraise that. So, now I am the appraiser, I send an attestation request and then the system actually takes it to an attester who will now go and certify, okay, this target server, that physical server is good, it does not have something. So, I get an attestation and then now I go and spawn. So, in some sense, if you look at it a very broader perspective, in this cloud I would like to monitor whether there is an attack, and in case there is an attack I would like to move this virtual machine to a new machine, new physical server within that cloud, and before I move I would like to have more information about that machine. And how do I get this information? I basically send some attestation and I get an attestation based on which I make a decision. So, how does a consumer go and ask for this attestation and get back an attestation? There are some patents for that, very interesting things.